Okay, so our group did not get to finish example 4, and you're going to need to know how to solve this system of equations to do the 3 problems from page 41. What we did was we graphed the line and the parabola so that we could solve it graphically. And I think we came to the conclusion that the line intersects the parabola at the points 5, 0 and 2, -6. So those would be the points of intersection that we should find when we do the work algebraically as well. So let's do that.
So we're going to use algebra to solve the system of equations. Remember, this was the line in the way we were given it, and then we put it into y equals mx plus b form. And we got this. So we want to find the x and y that make both of these equations true using algebra, which is what you're going to have to do on page 41 with the 3 problems. Graph them, see the solutions graphically, and also show that those are the solutions using algebra. Since both of these equations are equal to the same y-coordinate, I know that these 2 equations have to equal each other. So I am going to set them equal to each other. 2x minus 10 equals 2x squared minus 12x plus 10. And to solve this equation, it's a quadratic equation, I'm going to set one side equal to 0. So I'm going to start by subtracting 2x from each side and adding 10 to both sides. And that gives me the equation 0 equals 2x squared minus 14x plus 20. Now what I need to do is, I notice that everything has a factor of 2, so I'm going to divide both sides of the equations by 2. When I divide this by 2, 0 divided by 2 is still 0. When I divide this side of the equation by 2, I get just 1x squared minus 7x plus 10. And I noticed that this can be factored. If you didn't notice it can be factored and you use quadratic formula, you'll still get the same x coordinates of 5 and 2. But I'm going to go ahead and factor it because I think it's easier. So when you factor it, you get x minus 5 times x minus 2 would give me this equation. So when 2 factors multiply to give us 0 using the zero product property, then either the first product, x minus 5 is 0, or the second product, x minus 2 is 0. If x minus 5 is 0, add 5 to each side, you get x equals 5. And if x minus 2 equals 0, then x must be 2. So those are the 2 x coordinates, 5 and 2, that we got when we graphed them. To find the y coordinates that go with them, I just use these x coordinates in the equation. I can put it into this equation to find out what y is, or this one. I think this one's going to be easier. So I'm going to say that the y coordinate that goes with 5 is 2 times 5 minus 10. And 2 times 5 minus 10 is 10 minus 10, or 0. So when x is 5, y is 0, and that is one of my solutions. Same solution I got algebraically. When x is 2, y is going to be 2 times 2 minus 10. And that will give me 4 minus 10, which is negative 6. So the other solution is 2, -6, which is also here.